Recall from algebra that we write claims like this. A plus b squared is equal to a squared plus 2ab plus b squared. And when we say something like that, we don't mean it's only true of a and b. We could say that it's equally true of 1 and 2, or 1 and c, or more complex expressions, u plus v plus u plus w, the quantity squared. And we write it out in exactly the same way on the right-hand side. So that we know that when we write a claim like this, it applies generally to any value substituted for the variables a and b. What we want to see now is that the same is true of logical expressions. So when we write identities and inference rules, we write something like this: double negation. Not p is equivalent to p. Or let's use two variables, not p and q is equivalent to not p or not q. That was De Morgan. Or we can assert a distributivity property involving p, q, and r. What are p, q, and r in these sorts of expressions? And the answer is they're variables. Or if you want to think of it, they're placeholders for whatever expression we wish to place in there. Let's look at one of those three in particular and just see what we mean by that. So we have this De Morgan law: not p and q is equivalent to not p or not q. It's not true just of p and q. I can cross off p and q. I could put q and p. I could put them in the other order. I could put a and b. I could put aardvark and anteater. Or I could put a complex expression like this. It doesn't matter. The rule holds for any of these. Why? Let's take a look at how we proved De Morgan. We proved it with a truth table. And here's its truth table. We went p, q, p and q, not p and q, not p, not q, not p or not q. And then we showed that those two were equivalent, and we see that we got a tautology. It doesn't matter what the values of p and q are, we get a t. Now, when we did that, did it depend on what we called the variables? Let's look at it. So we have this column header is p, and this one's q. Could we have put aardvark or anteater? Well, almost. The only thing that matters, look here, is that when I say p and q, all I mean here is, when I say p, go pick up the value from the column that was labeled p. Similarly for q. As long as I change all the values along the top row consistently to mean pick up the value from the first column, pick up the value from the second column, then I'm going to get the exact same result. It really didn't matter what color or shape or name I gave to those columns. That's why we have a proof of the general claim for any expressions that De Morgan holds. That means that there's one thing that's really important if we do try to do substitution, and that is that we're consistent. So if we have that p and q or r is equivalent via the distributivity property that we've proved to this, and we go to substitute some other expressions for p, q, and r, we have to make sure, since, for example, here p occurs twice, that if we do substitute something else for p, we do it in both places. So we can, for example, if you tell me summer and night or hot, I can use distributivity, and I can get it's summer and night, or it's summer and hot. Fine. What I can't do is this. I substituted summer for this instance of p, and I substituted winter for that one, and now I get that it's summer and night, or it's winter and hot, which doesn't follow from my original claim. There's one other thing we can say about this. While you cannot take the same variable and substitute different values, you can substitute the same value for different variables. Remember, the only thing that matters is you're consistent. So again, starting with our expression and using distributivity as we've stated it, could I, for example, if you give me the expression summer and summer or summer, pretty silly, but maybe it got derived from something, the distributivity rule says that I ought to be able to rewrite that in this form. And That's fine, and we can see that it's fine. If we now continue with some computation and simplification, we see that this simplifies to summer, and this simplifies to summer, so we have summer or summer, and that simplifies, of course, to summer. And it's quick to see that so did this one. So we haven't generated anything that doesn't follow from the original premise. So we can substitute anything, and we really mean anything, as long as we're consistent in how we do it.